All right, one last example of partial fraction decomposition. This one is where I have a higher degree polynomial on the top. This is a fourth degree polynomial on the numerator of this fraction because it has x to the fourth as the highest power term. And I've got a second degree polynomial on the bottom. And in order to do these, you have to divide first. You want the degree on top to be smaller than the degree on the bottom in order for a partial fraction decomposition to work. And so the way we're going to do that is we're going to do division. And we're just going to do long division. Might have been a while since you've done long division. But we're going to start with putting the denominator out to the left of this division bar. And this is the way at least we teach it in the United States. Might be a little different if you're from a different country. But this is the way we do it in the United States. And then we think, well, x squared times what? What do you have to multiply by x squared to get x to the fourth? Well, just an x squared. If you multiply by an x squared times x squared gives you x to the fourth. So I'm going to put an x squared over that x to the fourth. Actually, no, I'm going to put the x squared over the x squared term. That's a little bit better. And then what I have to do, though, is multiply that x squared by all three of these terms over here. So x squared times x squared is x to the fourth. X squared times minus x is a minus x cubed. And I'm going to put it right underneath those x cubed. We'll keep them lined up. And I'm going to get a minus 2x squared. All right? And then you just subtract. But you do have to subtract that whole piece. Whole piece, the x to the fourth should cancel out. I've got minus a negative 3. Be careful there. That's going to become a plus 3x cubed. And when I subtract, it's going to be a minus 2x squared. All right, I'm going to add the next term to my sequence and then think, well, now what do I have to multiply by x squared over here to get the 3x cubed? Well, you have to multiply by a 3x. So I'm going to add a 3x up here above my division bar. And 3x times x squared gives us 3x cubed. But 3x times the minus x is a minus 3x squared. And the 3x times the negative 2 is a minus 6x. I'm going to subtract again. Remember to distribute that negative sign through as you subtract. 3x cubed minus 3x cubed is 0, just like I hoped. Minus 2x squared minus a negative 3, that's going to become plus. So I'm going to get 1x squared. And then it's going to become plus there, so plus 7x. I've still got a negative 3 down there. And one last time, x squared times what gives you x squared? Well, x squared times 1 gives you x squared. So I'm going to multiply by 1. X squared minus x minus 2. And one final subtraction. Again, you are subtracting a negative, so you're going to get 8x plus minus 1, right? 8x minus 1 in there. All right, and now I'm at the point where the degree of what I've got left is smaller than the degree of the polynomial in the denominator. So now I'm set. What I can do is I can rewrite this division as this integral is just x squared plus 3x plus 1 plus 8x minus 1 over the x squared minus x minus 2 dx. That's all inside the integral there. So I'm taking the integral of x squared, I forgot what it was, x squared plus 3x plus 1 plus 8x minus 1 over, let's go ahead and factor that denominator. I believe it factors as an x minus 2 times an x plus 1. All right, and the first part, that's really easy. I can just use our power rule to find that antiderivative. Do I want to do that now? Sure. X cubed over 3 plus 3x squared over 2 plus x plus, I still have to do the antiderivative of this last piece. It's going to be an a over x minus 2 plus b over x plus 1. I'm going to split it up like that. And I have that 8x minus 1, 8x minus 1 over x minus 2 times x plus 1 needs to equal a over x minus 2 plus b over x plus 1. And so that's, all right, get our common denominator there. We'll get 8x minus 1 equals a times x plus 1 plus b times x minus 2. And again, we want these to be true for every single value of x, regardless of what value of x we choose. But we can choose some nice values of x to make nice things happen. If x equals 2, the second term will just turn into 0. And I'll have 8 times 2, which is 16 minus 1, equals a times 3. So 15 is equal to 3a, a is equal to 5. And if x equals negative 1, I'll have a negative 8 minus 1 is equal to 0 times a, and b times negative 3. So negative 9 is equal to negative 3b, so b should equal 3. So I am looking at, going back to my integral, x cubed over 3 plus 3x squared over 2 plus x plus the antiderivative of 5 over x minus 2 plus the antiderivative of, oops, I left off an antiderivative symbol up there, 3 over x plus 1 dx. And these are also, you can do substitution if you need to, but it's like a 1 over u sort of thing is what we're going to end up down there. And so we're going to get natural logs. X cubed over 3 plus 3x squared over 2 plus x plus 5 times the natural log of x minus 2 plus 3 times the natural log of x plus 1 plus c. All right. And that would be our antiderivative. That's our answer that we have there. All right, let me jump over to this other application here, and let's look at a brief summary of this whole process. Oops, I think that's a little bit outside my area of recording. Well, I think you can see enough of it though. All right, so the different forms of partial decomposition fraction. If you have distinct linear factors down there on the bottom, if you've got a x minus 1 times an x minus 2, you're going to have an a over x minus 1, or x minus r1, and a b over x minus r2, and a c over x minus r3. For every distinct factor there, you're going to have a term a over that, a over that, a over that. If you have repeated linear factors, if you've got an x minus r to the second or third, you're going to have to repeat those factors. You're going to have an r, x minus r1, and x minus r, this should actually be r1 in there too, x minus r1 squared, x minus r1 cubed, all the way up to x minus r1 to the n power, with a letter over each one of those. And if you have that non-quadratic factor in there, then we're going to have an ax plus b over the x squared minus r1. If you got something there that doesn't factor, you should have an ax plus b over the top of that. Again, it's got to be something on there that you can't break it down. If you can break it down, break it down into one of these distinct linear factors. But if you can't, go with that. All right. Good luck, class. Again, there's a homework forum. If you have questions about your homework, as you're working on your homework, let me know. I will be checking those frequently, at least once a day, to answer those questions. But it is only once a day, so you can try to answer each other's questions, help each other out, or try to work ahead. The killer of online classes is procrastination. If you try to put everything off to the very end, it makes online classes super, super hard. So do it when you can. All right, good luck, and I'll hear from you in the forums.